Yeah, I'm gonna jump right in. Yeah, I don't need to say a lot more. This was a pretty good introduction. So I should just probably update my photo. This photo is like 2 years old. A lot of things have changed in the world in the last 2 years, and also all around my head. And actually, I need to admit, I'm a big fan of Fabian's dreadlocks. I used to have dreadlocks when I was still in high school. So I definitely like that. Yeah. So what are we gonna talk about today? As Olivia said before, it's like in these cloud native meetups, it's a lot about Kubernetes. So we're gonna talk about Kubernetes in this talk. And yeah, just one thing, I would like to have this as interactive as possible. I don't have a super strict agenda. I'm just gonna see how much I can squeeze into that half hour. So if you have any questions or want me to show anything, just feel free to drop it in the chat. Also, I'm not sure if you can unmute and just start talking. Would be fine with me. If you can't, use the chat. I'm fine with this. So yeah, what are we going to talk about? I think that the talk is called "What's Going On in My Cluster" and kind of revolves about the topic of Kubernetes observability. However, observability might be a bit misleading, as this kind of goes a lot of in this like application performance monitoring kind of space. So this one is really more about understanding and visualizing the things that are happening inside of a Kubernetes cluster. As Renata said, I'm not only working as a consultant in the cloud native space, I'm also teaching at university for distributed systems, and I have to explain and introduce Kubernetes to many people. We teach classes here at Novatec. I teach students, and Kubernetes is pretty hard in the beginning with all the different API objects and structures that it has. And normally you start off with the CLI, and it's kind of hard to get the idea what is actually going on there. And this is basically the reason for this talk, just to figure out, let's try to understand things a little bit better, make it easier for people to get familiar with the technology, adapt it, and be like enable people to use it in a better way. Now, so there are options. There are many kind of, I should say, altitudes on which you can enter and observe things in and around a Kubernetes environment. So we're going to look at a few today. We're going to start on a kind of entry level, the Kubernetes API. This is probably what everyone has already. Then we're going to look a little bit into service meshes and eBPF. And like the most advanced and specialized way of observing things that are happening in the cluster would be like logging and tracing. We're not going to go too deep into tracing, mostly because it gets too specialized and there's so many things there. One thing I wanted to highlight real quick, I'm not only teaching at university, I'm also like mentoring a lot of thesis works, and the foundation of this talk, or the basis for this, was given by a bachelor thesis from Yannick. So this is just a quick shout out to him. He's done a great job. So he should be mentioned here as well. All right, so I think I said that. Why are we doing this talk? Basically showing various open source options to improve the insights and understanding, diagnose health and what is going on in the cluster. So a quick disclaimer here. Let's just a quick look at the time. I'm only going to show open source and like free things. So there's of course plenty of commercial software out there to get better control and insight into a Kubernetes environment, but very often I'm not sure which of them might be the right ones for my clients. And so we start with basic building blocks out of the open source world, which will most likely help to identify the real needs in kind of observability that you really have. And if you know all that, you can still narrow down the scope and buy a commercial version if you want to have it. Now, most of the things that I'm going to show live, and I have different clusters, different tools. So not everything will probably work straight away. So hope you are patient enough. And yeah, so I said it before, this one is not going to be too deep about application-specific logging and tracing. It's more about really getting control and overview in the cluster. And of course, there's, I say here, no guarantee for completeness. So I should much rather say it's definitely a guarantee for incompleteness, because there's so many things out there that you can use. And probably I don't know all of them, and half an hour would not be enough. So most of you have probably seen this diagram. This is a screenshot of the Cloud Native Community Foundation landscape. This is about half a year old, so it's probably doubled since then again. So there's a lot of tools and technologies that revolve all around the Kubernetes ecosystem, so to say. And if you narrow down here a bit, like down here, there is one section for observability and analysis. And even there are a lot of tools. And some of them we'll see, and we also see others which might not even be listed in there. Now, before I dive in, I want to say maybe a few words about Kubernetes. So this is kind of an entry-level talk. If you haven't used it yet, just a few things to get started. So we have this platform that runs your applications. We have various roles there, people that deploy applications, that consume applications, and that observe applications. We're probably going to look a little closer at the deploy and more likely observe part. Now, if you deal with Kubernetes, you should be kind of familiar with a few concepts. So like all your workloads are being run in containers. Connor has just done a great intro of WebAssembly and also mentioned containers. So if you're at a Cloud Native Meetup, I kind of expect you to know what a container is. Now, the other thing are nodes. So this is the place where the containers are actually run. And Kubernetes kind of provides an API and an API objects to run those containerized workloads and in a scalable and efficient way on those nodes. So there are things like pods, replica sets, ingresses, services, deployments. These are all those API objects that you will most likely have to learn if you wanna work with Kubernetes. And today I hope to introduce you into a couple of easy ways. Now, these are the things that I normally show. I probably narrow it down to 2 or 3 because otherwise I might run out of time. In the end, and I hope you can see this all fine, it looks a bit blurry on my end. Now, to work with tools that access the Kubernetes API, they basically do the same thing as you would do using the command line. In the end, they kind of aggregate the data and bring it into a nicer visual form. There are various ways to do that. We will gonna see K9S as a command line option tool. Then we have 2 which are web-based. One is called Octant, one is called Lens. There's another one called Scope. Some of them run inside of the cluster, some of them run outside. The good thing here, and one thing important here in general, is also about how much are you going to pay, and I'm not saying pay in money, but pay in overhead for using those tools. And with those Kubernetes API-based ones, you don't really pay a lot because they, as I said, they're doing basically the same thing as you would do anyway. Now, all right, so I'm going to switch my screen here, and I hope you can kind of see this fine. So I'm can clear this. I'm having a couple of Kubernetes contexts here. I'm going to increase it a little bit. So I have a couple of clusters. So I'm going to use this one today. And when you basically start, the first thing you could potentially do is say like CTL get all, or like get all from all namespaces like this. And so once you do this, to get like a command line overview, you already see the part of the problem. In a normal cluster, there are a lot of artifacts in there, and that will result in a lot of like scrolling, sorting, and whatsoever. So K9S, the first one I'm going to show, is like a tooling which is also, it doesn't need much. It runs on the command line. and it kind of aggregates the visualization of what you see with the kubectl output. So in here, you can also change the clusters. If you want to work with different clusters, you can easily access the various namespaces, or you can say, you have like some options up here. I want to see all the namespaces. So if you do this, okay, this not working. So now I'm seeing all the pods in the list. This one also will give me an idea if and highlight things in red if things are not working fine. So I can easily identify, are things crashing? And then I can start looking into the things. Talking about looking into the things, if you just basically enter on a level of a pod, you see the various containers. If you have a multi-pod container, and this one I have like an application and the Istio sidecar. So if I go deeper in here, I would actually get the logs. Now there's nothing running on that application in the moment, so I don't have any logs. But basically, it's kind of if you're quick with your shortcuts, it's an easy way of jumping around in that environment. You can also like jump into an edit mode where you would get into your editor of choice and can modify the components. You can do port forwarding, displaying the YAML, and basic things that you would normally do with your UI as well. However, it's kind of still limited to the dimension of your command line. Another one, which I think I have started on the command line already. I have many tabs open, and I hope you're not getting as confused as I am. This one is called Octant. And this will start like a web server on your machine. So this one has apparently lost connection, so we can start it again. So I'm running Octant here. I hope you can see that. So this will start that application and bring it back into the browser. So this one, of course, gives you somewhat better navigation because you can use like that web UI. In here, you can also quickly switch between Kubernetes contexts, and within the contexts, you have like all the namespaces. So you can then go into this. Istio system is actually not the one I wanted. So if you have many, like I do in this one, you have to expand the selection. And then there will be a pre-sorted output for you, where you can see, okay, what are the things that I have in my cluster, like deployments, pods, replica sets, services. So especially if you're new, this is a good and easy way to start getting familiar with this and be aware of what kind of things are relevant, which Kubernetes artifacts you should be dealing with. There's also some kind of sorting here where you could say which are the parts that are under the discovery and load balancing section, like services, ingress, network policies, pretty much all the things that have to do with the network. Then you have the configuration objects and storage, and the workloads objects, and so on. So technically, you can do similar things like we just tried to do in K9s. So for example, I'm selecting this pod right now, and this will also show me, okay, we have a couple of containers. We have the init container, the backend container, and that proxy container. If I want to know the logs, I can here see I can select all the containers or just the one from my application. So nothing has happened here. I can also jump back to creation, and then I would see all the logs that have been happened so far. One additional cool thing is you can also okay, now this does not work today apparently. Normally, you can access a terminal here and do like an open a terminal in that application. Maybe this container didn't support it. Let me just see if I can probably take a pod where there is no sidecars, so it might not all of the containers might actually have a shell installed, so you can access that. If it doesn't work, we'll just move on to something else. So I'm trying this one again. So I basically have deployed a similar application in various namespaces to showing different functionality with it. Now this doesn't want to work today. The third tool I wanted to show is called Lens. And this one is actually not running in a browser, so this starts up a FAT client. All right, so this is basically now starting to connect. And so technically, it will do something similar as we've seen with Octant. So you have multiple clusters here, and then you have like an aggregated navigation of all the things happening in the cluster. So I can say, I want to look into what I have as pods. Now it will show all the namespaces, and I can narrow down or select multiple namespaces to optimize my view. Just trying to using that right here. So it shows you the high-level metrics, and I'm going to give this one another shot. So this one would actually let me, if this ever works, connect to a shell. So I can quickly, if something is not right, I can quickly jump into the various containers, look what's happening in there, and I think you kind of get the point. So I'm now basically in the container where this Java application is running. So with that, you can get pretty efficient and quick in navigating around and looking at the things in your cluster. So I'll try to move on, otherwise I might lose a bit of time. Now, look, or basically just to recap. So the things we could see are basically all the things that we could get with some sort of kubectl get command anyway, but probably not a lot more. Now, the real important thing, which is kind of missing here, I think, is you will not see the connection of the applications in your Kubernetes cluster. So you can see if like a pod is running, like what kind of memory it takes, or CPU, basically the container metrics, but you're not able to see who is talking to whom inside of the cluster. And how does this work? And so in order to get there, you need to go closer to the network. So one option to do this is with using service meshes. I mean, technically, service meshes can do a lot more than just providing observability, but they do that as well, because they will be very close to all the container workloads. So technically, for those who haven't seen that yet, how this works is we've already touched it briefly. So in every pod, we have at least one container running. So the pod is basically the smallest deployment unit in Kubernetes, which is managed by replica, stateful, or daemon sets. So but this is not the important fact here. The important fact is like how are we going to access that network traffic in the pod? So basically, if something is running within a pod, it's isolated and running by itself. It needs some kind of services to get exposed for like being reachable within or outside of the cluster. Now, a pod can hold multiple containers. And the important thing here is they will be running on the same IP address. So they share the same port range. And technically speaking, one container will see all the network traffic going through here. So if I have an application container, then that proxy container will see all the traffic going to that application container. So this might not be super helpful if it's only one pod. But if you have many, you can apply the same principle. So basically, you place an agent or a proxy inside of all of your pods, and then those proxies can aggregate those data and send it to like a control instance. So very often we speak here of like a data plane and the control plane. And this control plane now has all the information of network coming from those pods, and now it can correlate it and figure out, yeah, who is actually talking with whom, and are things going well? Is it too slow? Whatsoever. And with that, it's also possible to visualize that. So technologies here are Linkerd, Istio, and Kiali. Today, we're going to look quickly into Istio and Kiali. Kiali is basically just a visualization framework that you could put on top of Istio or Linkerd. Let me see if that connection is still there. So that's basically the way that it looks. We have a pretty similar, this is basically the same application as we had before. We have like an ingress that brings in the traffic. Then we have a UI component. This is like the service. This is the pod. And it goes to an internal component and then to a database. We can make things look kind of fancy and say we want to see the response time. We want to see some traffic animation. And then we can already see, okay, what is fast, what is slow, who is talking to whom, and so on. In case you're doing more advanced things with your deployment, like blue-green deployment or even canary deployment, you will be able to see that here as well. So I enabled this one with, with multiple versions of that front-end component. And now if I go down and say I want to have some request percentage, I can see that this one gets about 90 and this about 97, is about 3% of the traffic. This will probably level out to like 90 and 10 because that's the values that I've specified. So I can say this new version of the application is just being canary tested. And if I want to have more, I can change that ratio and eventually move it over to that new version. And I can easily use that visualization tool to say, is my traffic actually being routed correctly? And does the thing work as it is supposed to work? Yeah, so actually, you may wonder where this traffic is actually is coming from. I'm just running a kind of a while loop in some of the windows right here that basically just queries the web page very frequently. So this is not so super exciting. Yeah, technically speaking, to achieve that, we can go back in here. You need to have one of those sidecar proxies in each of your application containers. So you see that here in the list of containers, or if you basically go click in on that, and then you see this is the list of containers. We can check the logs on the various ones. This is actually the application, and this one is the one that collects all the network information. And in the end, this is all going to be summarized and then sent to the components in the Istio namespace, where things are being aggregated and visualized. All right, so that's that. And then I want to talk about one other thing, which is fairly new and pretty interesting. This one is called eBPF. And eBPF, if you have wondered, stands for Extended Berkeley Packet Filter. So if you hear that for the first time, I'm not sure if you're going to associate any kind of observability topic with that. It's probably not the primary use case, but it can be used for that really, really well. So I can't explain you all the way eBPF works, but I can try to summarize it really briefly. Technically, somebody explained it to me like, in a way, you can run sandbox code in the Linux kernel in a similar way as you can run like JavaScript in a web page. So it's kind of sandbox. It's not able to break out and do damage, but it still can run there. So the way this works, it can then grab kernel events from the Linux kernel and work on that, send it to a component in the user space, and then basically kind of evaluate it and process it there. So the important thing for us is all the kernel events that we can capture here, of course, also contain networking events. So with using that technology, you are on a very low level of the operating system and can collect all the network data and then basically use it for taking actions in a later step. Now, why is that so important for us in the context of Kubernetes? Now, Kubernetes, as I said before, in itself is also running on various nodes. And these nodes normally run a Linux operating system and a container daemon, and then all the containers on top. But of course, it's also possible to apply this eBPF functionality right on that level. So having said that, you can run like the eBPF kind of edge components on the various nodes, similarly as you would run the proxies in a service mesh environment. This time it's just like on the level of the nodes, where on the other side it's on the level of the pods. So footprint-wise, you will most likely have a lot less nodes than you have pods. So from that standpoint, it will only be installed on each of the nodes once, and then it can act in a similar way that this acts as the data plane, and then can send things to a control plane. Two technologies that have been around here one is called Pixie and the other one is called Cilium. I want to go quickly into using the Cilium one just to see, just to show you how that works. 1 second. So this one is still working as expected. What I need to do here real quick, I need to change my cluster context. So if you're interested, the one we just saw with the service meshes is running on an Azure cluster. The one I'm going to switch to now is running on Google Cloud. And yeah, one reason is backup. One reason is not all the technologies integrate super well with each other. So that's why I'm having different things here. Now, with that eBPF component, I mean, it's not very intrusive in a similar way as service mesh is also not so intrusive. It can be injected and taken out just at runtime. With the eBPF component, it kind of makes more sense to kind of set this up into the cluster once you set up the cluster, and then you can just leave it there, and it won't change anything afterwards. So I'm going to start this with this command. Okay, so this is potentially still running. Yeah, this one is still there. And as you can see, it only discovers those components which actually have some network traffic inside. So if I switch to another workspace, like for example, the Cube System workspace, we can see all the connection between the components in that workspace. So we have the Cube DNS, which pretty much every component connects to. We can also see this one goes into the other namespace where we have that backend component running. I will just try to bring some traffic onto this one as well. I wonder why. So once I start with this and switch back to that other namespace, we should soon see, okay, now it picks it up. So there's now traffic from the outer world coming into our cluster. We can see which port it traverses from the UI to the backend. Both of them talk to the Cube DNS because they need to look up the other components in the application. And down here is everything in like tabular format. So technically, eBPF is of course also possible to measure the timestamps. These are not displayed in here in that UI. Maybe this will come later. It's a fairly young product. But anyway, I mean, with this visualization, it's of course a lot easier to explain to people what is happening in a Kubernetes cluster, as opposed to like very long kubectl outputs, or even worse, digging through some YAML or JSON files. All right. I'm not actually sure when my talk exactly started. Maybe in the private chat, let me know if I have a bit more time. Now, I still have 5 minutes. Okay, that's good. So looking back, now we've seen the Kubernetes API, we have seen service meshes, we have seen eBPF-based kind of introspection of the cluster. And logging and tracing, of course, will then be very application specific. Like all the things that we have seen so far don't really care much about if you write your code in WebAssembly or like you're using WebAssembly or using Java or whatever, because they only operate on the level of the network. Now, with tracing, things would be very much application specific. So I decided not really to demo much about that, because we're not here to like figure out if there is a problem in that application and where it would be. Now, I can just basically, this is like from our Kubernetes class. If we look into this, there's like a section about traces, what that will change. So in here, in the end, you would be able to go down to like a class and method level. And this is something which will need instrumentation of your code. And this will significantly also change the footprint of the monitoring. Now, this is the cool thing with service meshes and eBPF, that it doesn't really change that, because it listens to the traffic on another level. Of course, it cannot go fully into the application, but if you have like something being based on microservices, it will definitely already help you to isolate slow running components, or figure out why is the traffic flow not exactly how I wanted it. Maybe the problem is not even in the level of that depth. Maybe it's in another level of configuration. So, however, if you want to find out what would be a good solution for you and how are the other tools playing together, there's an open source project called OpenAPM.io, where pretty much all of the vendors and providers of open source toolings around monitoring put their components in. And what you can do with this is just basically start building. So we have categorization in storage, in visualization. And so I could say, for example, yeah, I want to use Kibana. And then Kibana shows up on that landscape. And then I can figure out what would be something that could feed into Kibana. So that could be like Elasticsearch. And what could feed into Elasticsearch? Quite a lot. And so this is kind of a compatibility matrix of all those toolings. So as you can see, this would be very tough for me to all show that. So I much rather recommend you to use that side. If you see anything which is wrong, please just like submit a problem or do a pull request. As I said, it's all open source. If you think there is something missing technology-wise, which is not listed here yet, of course you can edit too. But those things also make some nice architecture diagrams for slides if you want to show that to your management or so. All right. So I think that was quite a bit of a rush through all those various things that I have been using in the past so far to get a better grip, so to say, about the happenings in my Kubernetes clusters. And if you're dealing in a similar situation like me, working on different cluster environments, potentially in different projects and so on, some of those tools can be really helpful because sometimes very obvious things are not really visible straight away. And I hope I was able to show you a few new things here, and you didn't know all that already. I mean, as I said, it's like all of the things are open source, so I'm not getting any money whatsoever for recommending those. My recommendation is just really try them out and like give feedback to the community in order to make those things better. And yeah, with that, I would like to say thank you and open the line for more questions. I saw there's something going on in the chat, but that discussion around Bosch, which is of course a very great technology as well.
So, Matthias,
yes,
thank you for your talk. And as you've highlighted, there has been a discussion around Bosch, and I think people have mixed feelings around it. But we pick up on that later. I just wanted to express thanks for showing us this. Some of those tools we are using on a daily basis in our own stack, especially Cilium, and I have been glimpsing towards Pixie, but at the moment it seems a little bit hard to self-host that. And what never ceases to amaze me is that you can now simply install something with Helm into a cluster and get that level of observability, when like 10 years before, and I've been always working in infrastructure, you had to pay like so many bucks a year to vendors like Juniper to get good flow control to see your network traffic, and now you get all of that, like, here it is. It's totally amazing.
I totally agree. I mean, I was not, my background is more like from the development side than from the infrastructure side. But then in APM, you always paid in configuration and restarting and making sure everything runs well. And then in the end, sometimes it wouldn't, and you were not sure if the metrics reliable that I'm going to get. So with like that service mesh eBPF level, what I really like is the fact that it doesn't change or modify your running application. You can basically just plug and unplug it and then configure it the way you like, and that makes it like really easy. So yeah, I'm totally agree with what you say.
Yeah, and now we're talking about application monitoring and observability in specifics. What I'm wondering, do you have something to say about distributed tracing or maybe metrics collection with Prometheus and how to put that together?
Well, yeah, I mean, Prometheus is more like a framework for collecting all kinds of data, and then we very often, of course, combine it with Grafana for displaying the output. I mean, I think I showed that briefly, that you can actually use the Jaeger tracing also with service mesh as an input source. So even then, you could trace your requests across your cluster without going into the application. You can, of course, combine it then with an application agent that would provide you application level details. So that would probably be my next logical step in that presentation. But as I said, that was really my point of focus. And yeah, we use that a lot. It starts to kind of evolve into a way that even though there are many options in the Kubernetes like landscape, these ones tend to become kind of standard, which is of course also a good thing if you don't need to use 10 different solutions all the time in 10 different environments. Yeah, but I mean, they became successful in that way because they were so extensible and adapted to all those needs. And it's still a lot of a task on our side to plug them together and make them work as they want to. But for example, we have like a Novatec in-house APM solution, which is also open source, and that completely works with those tools. So all the data is visualized into Grafana, and you see the flows there as well. But you, again, in this case, you need to install agent level to collect Java information. We're doing mostly Java things there. And that's like the downside of things. Once you go into tracing, you become like framework or programming language specific and need specific collectors for that. And that's what the tools that I've shown today do not require, and would still give you an initial insight to the things.
Yeah. So with regards to tracing and stuff like that, I have, in my experience, we're using OpenTelemetry for transport, and that pretty much works with many of those systems. We're using the Grafana stack, so Loki and Tempo for tracing, and that integrates very well with each other. We're also something I don't stop being amazed about, because for developers, and we're the infrastructure guys delivering platforms to developers, and it's often super helpful to have all of these tools at hand and cobble together and give them visibility. Solves problems much faster than before, where you were diving through logs and all of those things. We have a question from the chat, and it's a very personal one, I guess. Someone asked, which of the shown tools are your favorite ones?
That's tough. I mean, I would probably say I never leave the house without K9S or something. Like, I mean, just to have something very quickly to get something done without requiring a browser and quick access to like logs, switching between namespaces and like having something visualized quickly. So this is just like a command line installation, and you run it with K9S, and then it pulls your current Kubernetes context and starts displaying things. But I also use that, I actually should say, most often those entry-level tools are almost sufficient. I mean, they provide some very good quick insight of what is going on. And it's not the most common case that I need to start debugging on a network level. I mean, what I really love that Kiali visualization, especially if you do canary deployments, but that's kind of a very advanced scenario. I mean, we don't really have that all the time with all of our client implementations. If you do things like that, it's super powerful. And yeah, I really liked Cilium. The problem is I didn't have enough time yet to really get all the way through what it can do for me. I mean, with the things that I have shown today, I probably have only scratched 10% of what eBPF and service meshes can do for you. And I really would like to go in there more. And yeah, I would say these are probably the ones. But in the end, I often see myself that if I've used Octant for a while, then I'll use Lens again, because I don't know, just like seeing something different. In the end, there's no clear favorite. My recommendation, and this is a good thing about it, is just try them. It's super easy to get started with it. Actually, I forgot one thing. One thing I wanted to show today as well is like Argo Cd. This is something that I've used quite a bit recently, and it visualizes the deployments really well as well from a CD standpoint. So you're not seeing the runtime, but you're seeing also the rollout and how it basically differs from what you have in your Git repo and so on. But it's very Kubernetes native, so it has all the artifacts and displays them in a right order. So it's very helpful as well to understand things. But yeah, cool. Maybe on another talk.
Yeah, maybe. I guess we can make that happen. Matthias, thank you very much. And with that said, tools, and you need to try them out. I guess we can hand over to the next speaker that will definitely show us how that works with this platform, Automi. Thank you very much, Matthias.